Hello students, good evening. So we are in the session 5 of this electric potential and capacitors. This is already in session 4, right? We were discussing about the electric potential due to a dipole. Okay, so already electric potential due to dipole, if you have a dipole, right? So dipole is what? A combination of equal and opposite charges, dana. So we looked at what is the electric potential on the axial line and the mother electric potential on the equatorial plane. Okay, so that I'm already session 4 la paathirukom. Iniki enna we'll start with the discussion of electric potential due to dipole at a general point. So idhula we'll particularly focus on the short dipole. Okay, so paranga we have a short dipole that is here. Short dipole sonna what it means, the so paranga, so from the center of the dipole we are marking a point P. So the r value, distance of the point from the center of the dipole will be very high in comparison to A. That is what is the concept of the short dipole. Okay, so now we have to look at what is the potential at the point P. See paranga, we have a charge Q, plus Q and minus Q. What is the direction of the dipole moment? It will be from negative charge to positive charge, dana. What is the value of this? P will be equal to what? Q into 2A. So the length of the dipole is what? 2A. Okay, and as per this representation, right, the distance from positive charge to point P is what? R1. Distance from negative charge to point P is what? R2. Adhanala the potential at point P because of positive charge will be what? Q by 4 pi epsilon naught into R1. The potential because of negative charge at point P will be what? Minus Q by 4 pi epsilon naught into R2. So what is this? அப்படியே அந்த 1 by 4 pi epsilon naught common வரும். Q by R1 minus Q by R2. Okay, so this is the total potential. What is the total potential at the general point we are taking? 1 by 4 pi epsilon naught Q by R1 minus Q by R2. Okay, so in the expression இப்போ நம்ம simplify பண்ண போறோம். So this is what is the potential at the general point P. Okay, now we are going to simplify this, and whenever we are talking about a general point, right, we will represent general point by using the distance of the point P from the center of the dipole R and the angle between this is the position vector of the point, right? Then this is the position vector of the point R bar. The angle between the R bar and dipole moment vector. So generally whenever we talk about a general point, right, with respect to dipole, eppadi and the point number represent pandradhu we will talk about what is the distance from the center of the dipole. And madri theta is what? The angle between the dipole moment vector and the position vector of the point. Okay, so these two we will use to represent any general point with respect to the dipole. Okay va? So paranga, we are having R1 and R2 in that formula. And the potential formula we are getting R1 and R2, right? But we should not have R1 R2 in the final expression. Final expression la R1 R2 should not be there. They should be in terms of what? R and theta. It should be in terms of R and theta. Okay va? Now we can see two triangles here. So one triangle where A R1 R, these are the sides. Okay, second triangle is the triangle where R R2A, these three are the sides. So we are basically seeing two triangles here. This is the first triangle, this is second triangle. Now in triangle, right, we have relation between the side lengths and the corresponding angles. In a triangle we will have a relation between the side length and the corresponding angles. Adu nama ipo paaka porom. So we are not going to do the derivation of that relation, we will just use the relation. Okay, if you look at the R1 square, the r1 square value will be r square plus a square minus 2ar cos theta. So if you are having an angle theta, right, theta is what? Enclosed angle between the sides a and r. The third side r1 square will be equal to what? A square plus r square minus 2ar cos theta. This is the relation between the side lengths. Here this is theta, means this will be what? Is 180 minus theta dana. That side theta means the angle on line is what? 180. So in the pakka 180 minus theta varum. Inga parunga r a. Third side is what? R2. So parunga r2 square will be equal to what? R square plus a square minus 2ar cos of 180 minus theta varum. What is cos of 180 minus theta? Minus cos theta. Adana minus minus will become plus. So what is it? R square plus a square plus 2ar cos theta. That is our r2 square. Okay, va? So r1 r2 values we are getting in terms of what? We are getting in terms of r and theta by using the relation between the sides of a triangle. So a triangle edutha adil the two sides in the first triangle, right, we are having the two sides, right? What are the two sides in the first triangle? R and A. The angle in between them is what? Theta. Third side square is equal to what? A square plus r square minus 2ar cos theta. And the second triangle the angle will be what? Minus 180 minus theta varum. Okay. Adanala plus 2ar cos theta is coming. Okay. So these are the two results we have. R1 square is equal to what? R square plus a square minus 2ar cos theta. R2 square will be what? R square plus a square plus 2ar cos theta. Now we will try to further simplify it. Here namakku enna venum parunga, idila 1 by r1 venum, and the 1 by r2. So look at this now. In the right side la r1 square formula mattum parunga, r1 square formula mattum parunga. So right hand side la we will take r square common out. Common edutha first term enna varum? 1 will be remaining. Idila r square kadayadu. So you will get what? A square by r square varum. Inga already there is a r in the numerator. We take r square common, means denominator la we will have one more r remaining. Inga parunga ipo multiply panna partha what is it that you are going to get? Multiply panna varum r square minus 2ar cos theta plus a square. Okay va? So why we are writing it is because we want to make use of some mathematical simplifications. Adukada we are trying to write it like what? R1 square is equal to what? R square into the remaining term. Ipa parunga, when we are saying the value of r is very very high in comparison to a, apadi sonna this a square by r square, right, will be very negligible. A by r itself will be small. Adu nama square panna a square by r square will be what? It will be very very small. But say for example a by r, like look at it like a 1 by 100 madri, then a square by r square will be what? It will be 1 by 10 power 4. It will become very small. So adanala we can just neglect this a square by r square. Why are we neglecting it? Because our assumption is what? Short dipole dana. So in short dipole a will be small in comparison to r. Then a square by r square will be even more smaller. Adanala we are neglecting that a square by r square term. Neglect panna, we will just have what? R1 square is equal to r square into 1 minus 2a cos theta by r. Okay va? So that is how we are getting this final expression. And if you take the other one, this r2 square, adana made the simplify, what we are going to get? Inga minus plus varum. So r2 square will be approximately equal to what? R square into 1 plus 2a cos theta by r. R1 square la minus varum, r2 square will be get as plus. But observe panni parunga, we are looking for 1 by r1 and 1 by r2. So in the expression, right, what we can do is we can take a square root on both sides. R1 is equal to r into 1 minus 2a cos theta by r whole power half. Okay, the reciprocate panna, what you are going to get? 1 by r1 is equal to 1 by r, 1 minus 2a cos theta by r whole power minus half varum. Okay va? So look at this one, this 1 minus 2a cos theta by r whole power minus half. This is like a binomial expansion. This is like a binomial expansion where the expansion is what? If you have 1 plus x whole power n type, here x is very small. Why? Because a is very small in comparison to r. So the expansion can be taken up to only the first and second term, which is what? 1 plus nx, means 1 plus n is minus half into x is what? Minus 2a cos theta by r. இங்க பாருங்க, minus minus will become plus, 2 cancel ஆயிடும். What you have finally? 1 by r1 is equal to 1 by r into 1 plus a cos theta by r. அவ்வளவுதான். What is it? 1 by r1 is equal to what? இது எப்படி வருது? By using the binomial simplification. So 1 by r1 is equal to what? 1 by r into 1 plus a cos theta by r. Okay va? அப்படியே நம்ம அந்த r2 square formula எடுத்து நம்ம simplify பண்ணா என்ன வரும்? So இங்க ஒரே ஒரு difference என்ன? Where you have a minus, here you have a plus. அவ்வளவுதானா? So இதுல இருந்து என்ன வரும் பாருங்க? 1 by r2, right? That will be coming like this, 1 by r into 1 minus a cos theta by r varum. Okay, so what we are going to get? 1 by r1 is a what? 1 by r into 1 plus a cos theta by r. 1 by r2 will be what? 1 by r into 1 minus a cos theta by r varum. Now the thing is what? The paranga potential formula already we can take q also common out. So q common out, what you will have? 1 by 4 pi epsilon naught q into 1 by r1 minus 1 by r2 dana. Already we get a simplified formula circa. 1 by r1, what is it? 1 by r into 1 plus a cos theta by r. And the 1 by r2 we get it. So we just have to substitute them. Okay, so what we do in this simplified potential formula, right? What we are having? We are having q common edutha 1 by 4 pi epsilon naught 1 by r1. See, what is 1 by r1? 1 by r into 1 plus a cos theta by r. Okay, so 1 by r into 1 plus a cos theta by r minus, what is 1 by r2? 1 by r into 1 minus a cos theta by r. 1 by r into 1 minus a cos theta by r. Okay va? So q by 4 pi epsilon naught. Inga paranga, this is what? 1 by r plus a cos theta by r square minus 1 by r plus a cos theta by r square. Plus minus cancel aidum. What we'll have? Q by 4 pi epsilon naught 2a cos theta by r square. Idhula paranga, what is q into 2a? P, right? What is q into 2a? P, the dipole moment, right? So what are we getting? Q into 2a dipole moment substitute panna, what we will get? We will get the final expression. Paranga, what is the final expression? We will have 1 by 4 pi epsilon naught q into 2a p dana. So p cos theta by r square. So this is what is the potential because of a short dipole at a general point. So general point p edutha, general point is represented by what? The distance of the point from the center of the dipole r. And the madri theta, theta is what? The angle between the position vector of the point and the dipole moment vector. Then what is the potential at that particular point? 1 by 4 pi epsilon naught p cos theta by r square. Paranga. So this is the potential at the general point. We can verify the previous results also. Already we get the previous results. The potential at a point on the axial line, potential at a point on the equatorial plane. See, equatorial plane, what is the conclusion we had? Potential any point will be 0, right? Now equatorial point and so on, this is perpendicular to the equatorial point, right? The perpendicular to the axis, which means theta will be 90. So in the formula theta 90 substitute panna, what you will get? Cos 90 0 dana. So v will become what? 0. So whatever the results we have before, right, we can verify them by using the general formula. General formula will be, this is for what? For the short dipole. Okay, this is not for a regular dipole, short dipole. Short dipole and the length of the dipole, we will take it to be very small in comparison to the distance of the points. Okay, so in the formula nama, what is it? Potential at a general point due to the dipole. Short dipole is what? 1 by 4 pi epsilon naught P cos theta by R square. Okay. Now we look at potential due to a charge ring. The charge ring, and so now we'll assume that the charge is on the perimeter or the boundary. Here we'll consider it to be what? Uniformly distributed. Another, we'll consider that the charge is what? Uniformly distributed. Say for example, we are giving a charge Q to the ring and Hkonga. How much charge we are giving to the ring? Charge Q. Okay. The radius of the ring R. We are marking a point P, which is the distance small r. Small r is what? Distance of the point from center of the ring. Okay, so we'll take a small charge element or a charge element dq edunga. Angle what is the distance to the point? Is a right angle triangle dana. So hypotenuse is what? Base square plus height square. So the small potential at the point P because of the charge element evaladi 1 by 4 pi epsilon naught dq charge value divided by distance root of capital R square plus small r square. We are requiring the total potential because of the ring, right? See paranga, wherever you take the charge element, the distance from that element to that point will be same, root of r square plus small r square. And potential is a scalar, right? Here in the directions concept of Radu. So when we want to find what is the total potential, we'll have to integrate this. Integration 1 by 4 pi epsilon naught dq by root of capital R square plus small r square. 4 pi epsilon naught constant. Okay. Root of capital R square plus small r square also constant. Remaining is what? Integral dq. Integral dq on what is it? We have to add up all these small charge elements, right? Add panna, what you are going to get? We will get the total charge on the ring. What is it? Capital Q dana. The total charge on the ring is capital Q. So paranga, what is the final formula? V is equal to capital Q by 4 pi epsilon naught root of capital R square plus small r square. So this is the potential due to the charge ring, uniformly charged ring, potential at a point on the axis of the ring. In the point P, we are taking point on the axis of the ring. Okay, potential formula. So we'll just have to remember all these formula results. So that maximum we will get questions. If you are getting question means we will get straight questions based upon the formula. So what is the potential formula, final formula? Q by 4 pi epsilon naught into root of capital R square plus small r square. Smaller is what? Distance of the point from the center of the ring. Capital R is the radius of the ring. Charge is Q is what? Q is the charge given to the ring. Okay, va? So this is the potential due to a charge ring at a point on the axis. The potential is changing because of the smaller value. Potential is changing because of smaller value. When potential becomes maximum, potential is related to R as R square. So potential is going to be maximum because the R square is coming in the denominator. So V will be maximum when R square is 0. Means what? We are at the center of the ring. So at that point, what is the potential value? Q by 4 pi epsilon naught. The small r square value will be 0. 0 means where we will have root capital R square. What is root capital R square? Capital R. So this is the V max value. Then this is the general, any point which is the distance smaller from the center of the ring, q by 4 pi epsilon naught root capital R square plus small r square. If you take the point at the center of the ring means again the potential is going to be maximum. Other value anna q by 4 pi epsilon naught into capital R. Okay va? So this is about the potential due to the charged ring. After that we talked about this spherical shell, charged spherical shell. The equivalent will be charged conducting sphere. Equivalent because the behavior of the shell and conducting sphere will be same. The charge will be on the outer surface. For the conducting sphere also charge will be on the outer surface. So the electric field because of the spherical shell is same as that of the electric field due to the conducting sphere. That already when we discussed about the electric field derivations. We want to find out the potential due to the charged shell. Electric field we have discussed about point P, which is outside the shell, on the shell, inside the shell. So here also we will discuss same. First we are looking at a point which is outside. The point is what? Outside, at a distance r from the center of the shell. Center of the shell we are taking a point which is the distance r. The charge given to the shell is q. Okay, so capital Q or small q, whichever we want to use. Okay, the radius of the shell is capital R. So the result we are going to get will be same for both charged shell and sonna. What is it? We'll have the outer surface mattum. Inside will be what? Vacuum. But charged conducting sphere will have a material inside, but charge will be residing only on the outer surface. Adhanala the result will be same both for the charged spherical shell as well as charged conducting sphere. Okay va? So we are looking at what is the potential at the point which is outside. We will use the relation between the electric field and potential. In the calculation we will use the relation between what? Electric field and potential. Okay, so look at what is the electric field at a point outside due to the spherical shell. We are taking the spherical shell to be having a charge small q. Okay, what is the field outside formula? What is it? 1 by 4 pi epsilon naught q by small r square. Small r square is what? Distance of the point from the center of the shell. Okay, distance of the point from center of the shell. The electric field radially outwards. Electric field radially outwards. If you give a small displacement dr along the direction of the electric field, if you give a small displacement dr along the direction of the electric field, as you move a distance dr along the electric field, the corresponding potential difference will be small value dV. The corresponding potential difference will be small dV. We have a relation between them, right? What is the relation? Minus dV by dr is equal to electric field. We are saying d outside. Why? Because we are trying to tell that, okay, we are calculating the potential outside the spherical shell. So formula na, what is the relation? Minus dV by dr is na. When you move a small distance dr in the direction of the electric field, what is the relation between the change in potential and the electric field? Minus dV by dr is equal to electric field value. So electric field value another 1 by 4 pi epsilon naught q by r square. What is electric field value? 1 by 4 pi epsilon naught q by r square. We'll just rearrange it. Rearrange pannanga. Ippadi and the dr number right side eduthu pola. Minus dV is equal to 1 by 4 pi epsilon naught q by r square into dr. Okay va? Now from this point, which is at a distance r from the center of the shell, you take it to infinity. We give small displacement, we take it to infinity. We are doing the integration on both sides, right hand side limits enna varum small r to infinity, because we are changing the position value from small r to infinity. Okay, left hand side la the potential at this point is v, potential at infinity let us take it as what, v infinity. Potential at infinity எவ்வளவு, v infinity. Okay, so இந்த LHS மட்டும் பாருங்க, what is this LHS? Minus, see minus அப்படியே வெளியே வரும், so minus வெளியே வந்தா what is it? So we'll just look at the LHS part மட்டும், தனியா பண்ணலாம். we'll look at the LHS part. Okay, so LHS part மட்டும் பாருங்க, what is there in the LHS? Minus வெளியே வந்தா what you will have, it's like integral dv, v to v infinity. Okay, integral dv means what, integral x dana, which is what, minus into v infinity minus v, which is what, v minus v infinity. Minus ulla pona it will become what, change the signs, right? So it will be what, v minus v infinity. This is the LHS oda value, LHS integration. Okay, இப்போ நம்ம RHS பார்க்கலாம். RHS பாருங்க, இதில் 1/4 pi epsilon naught q எல்லாம் கான்ஸ்டன்ட் அப்படியே வெளியே வரும். ஸோ 1/4 pi epsilon naught நியூமரேட்டரில் ஒரு q வரும். integral r to infinity 1/r square dr. இது என்ன தெரியுமா, this can be seen like what, r power minus 2 dr. So already நம்ம கிட்ட ஸ்டாண்டர்ட் ரிசல்ட்ஸ் இருக்கா, what is it, integral x power n dx, what is it, x power n plus 1/n plus 1 தானா. So q/4 pi epsilon naught r power minus 2 plus 1 by minus 2 plus 1, which is what, இது என்ன தெரியுமா, இது minus 1/r வரும். r power minus 2 plus 1 means r power minus 1, denominator minus 1, which is what, minus 1/r. So minus 1/r நம்ம limit substitute பண்ணணும். What are the limits? r to infinity. So இங்க பாருங்க, q/4 pi epsilon naught minus 1 by infinity minus of 1 by minus r. So minus 1 by infinity means what, 0 தானா, minus minus plus ஆகும். So what is it, q/4 pi epsilon naught into r. Another, what is the value that is coming, q/4 pi epsilon naught into r. Okay, so this is just standard, அப்படியே நம்ம அந்த integration பண்ணிருக்கோம் based on the standard results of the integration. So இப்போ நம்ம கிட்ட final value இருக்கா என்ன, the LHS part of the result and the மாதிரி RHS part of the result. So we'll just equate both of them. So LHS integration என்னது, v minus v infinity தானா. What is the RHS value? RHS value enna, it is q/4 pi epsilon naught r. So பாருங்க, what is it that we'll have, LHS la we'll have v minus v infinity, that is equal to what, RHS la q/4 pi epsilon naught into r. So if the point is infinity, right, the point is at infinite distance from the charged object, means there we will take the potential to be what, 0 dana. That is the reference. When the point you take is at infinity, it is very far, the influence of the charge will not be there. So adanala the potential at the infinite location will be always 0. So we are getting the final answer. What is it, the potential at the point r that you take and write because of the charged spherical shell, எவ்வளவு, q/4 pi epsilon naught into r. Okay, so why we are doing the derivation is to show எப்படி இந்த result வருதுன்னு சொல்லிட்டு. இல்லைன்னா we could have just seen the results and moved on. But if you understand how the result is coming, right, you will feel a little bit more confident while remembering the formula. But நமக்கு என்னன்னா, we need to remember the formula. Maximum NEET level we will not get questions asking us to do the derivation. இந்த மாதிரி derivation அதெல்லாம் வராது. So we just have to look at the final result. But derivation நமக்கு தெரிஞ்சா we will be feeling more confident while remembering the formula, and also the memory of keeping these things will be even more better. Quick recall பண்றதுக்கு will be more comfortable. Okay வா. So பாருங்க, we are able to get the result, என்னது, the potential due to the charged shell at a point outside. What is the formula? 1/4 pi epsilon naught into q/r. What is the formula for this? 1/4 pi epsilon naught into q/r. Okay va. இதுக்கப்புறம் தெரியுமா, if you want to look at a point on the surface point and சொன்னா, that smaller value, smaller is the distance of the point from the center of the shell தானா. smaller approaches capital avladha. If you keep bringing the point closer and closer to the surface, what is going to happen? Smaller value will approach capital R avladha. So the potential on the surface, what is it? Idana the V surface and solala. What is the potential on the surface of the shell? As it is in the formula enna varum, smaller badala will get capital R avladha. So 1 by 4 pi epsilon naught q by capital R. Okay. Other than the, we need to look at what is the potential inside the charge shell. So surface length, if you are moving any direction into the shell move panna, remember inside the shell electric field level is 0 dana. Inside the charge shell electric field level is 0, which means when you move in any direction, formula anadi minus dv by dr is equal to E abudana. So E evala 0 means dv will be 0, means surface la nama ulla move panna potential difference will not be there. Potential difference will not be there means what? Whatever the potential on the surface of the shell oda surface mela evala irko, any point inside, or the center point agatum, or wherever you say inside the shell, any point you take, everywhere the potential will be constant or same. Everywhere the potential will be constant or same, and the value will be equal to what? Potential on the surface of the shell. The value will be equal to potential on the surface of the shell. Idana theriyuma, idu verum and the charge shell mattum kadiyadu. The result will be true for the conducting sphere also. Ipo namakkitta irukra results theriyuma, potential outside formula na 1 by 4 pi epsilon naught q by smaller. Smaller means distance of the point from the center of the shell. Same formula will be there for the conducting sphere. Adukku same formula da. Potential on the surface smaller ku badala capital R varum. Because inside the shell electric field is 0, adanala when we move from surface length, when you are moving into the shell, right, potential change agadu, which means the potential value at any point inside the shell, any point, even center point of the shell also, any point inside the shell will be same as the potential value in the surface of the shell. Adoda value enna 1 by 4 pi epsilon naught q by capital R. So this result is true for the charged shell as well as for the conducting sphere. Conducting sphere mattum kadiyadu, you take any object which is made up of conducting material. You take any object made up of conducting material. Adala enna theriyuma, take any random object. Ipo paarenga idu oru conducting material idu panna object vechukonga. Surface length when you move into this is what? Object made up of conducting material. Okay va? Surface length when you move inside, right, ulla electric field value evada 0, which means potential difference varadu. So as you move from surface of the conductor to inside, right, not only spherical conductor mattum kadiyadu, for any type of conductor the potential inside will be same as the potential everywhere inside. Ella edathula. So inside the conductor, anywhere inside, right, potential value will be constant or uniform, which will be same as the potential value on the surface of the conductor. Eppadi varudana, when you move from the surface of the conductor to inside, electric field is 0. So dv oda value varadu, dv becomes 0, which means what? Potential difference is not there, means any point inside the conductor, potential will be same, everywhere same, and the value will be equal to the value of the potential on the surface of the conductor. Okay va? So your important result here already, I think in one of the previous year neatly in the madri question ketirukanga, based on the potential of a conductor. For a conductor, potential inside everywhere will be same, which will be equal to potential on the surface of the conductor. Okay va? Same as in the charge shell agatum or the conducting sphere. Adukku appadida, potential everywhere inside will be same, which is equal to the potential on the surface of the shell or surface of the conducting sphere. Okay va? So this is about the potential due to the spherical shell or a conducting sphere. Other than we will go to the next one, which is our charged sphere. அதுக்கு போறதுக்கு முன்னாடி we look at this graphical representation. ஏன்னா ஆல்ரெடி நம்ம அந்த electric field கேஸ்லயும் நம்ம பார்த்திருக்கோம். There can be good scope for getting questions on the graph analysis. இங்க பாருங்க, inside as well as on the surface potential எவ்வளவு 1 by 4 pi epsilon naught q by capital R. இங்க பாருங்க, so we are plotting the potential with respect to small r. Small r is what? Distance from the center of the shell. So 0 means what? We are at the center of the shell exactly. Angle move pannittu we are coming out. So till we come to this capital R, we are inside the shell. So potential everywhere is same, which is equal to potential value on the surface of the shell. அதுக்கப்புறம் formula என்ன? Potential outside is what? 1 by 4 pi epsilon q by small r. Means potential is related to at what? Proportional to 1 by r. அதனால it will be what? Decreasing curve. பாருங்க இப்படி வரும். So this is the graphical representation of potential due to a charged shell. Conducting sphere also same thing as it is. Conducting sphere also same thing. So inside it will be constant, அப்படியே horizontal line வரும், அதுக்கப்புறம் decreasing graph. ஓகேவா? So graphical representation of both electric field as well as potential due to the charged shell, and other one is what? Charged shell and conducting sphere will be same. The other will be a sphere, charged sphere, which is made up of non-conducting material. Adana. The other is what? A charged sphere, which is made up of non-conducting material, where the charge will be fully inside the volume. Okay. So adu நம்ம பார்க்க போறோம். So what is the potential due to a charged sphere? So again we are assuming that it is made up of non-conducting material. So the charge will be fully inside. இங்க பாருங்க இப்படி. So if you are giving a charge q, means this will be fully inside the, means it will be occupied in the entire volume. Charge will be occupied in the entire volume. இங்க என்ன தெரியுமா? Again we will begin with a point outside. We will begin with a point outside. Okay. What is the electric field? In the same concept. You want to find the potential, means we will use the electric field order relation. Outside paranga, what is the electric field? 1 by 4 pi epsilon naught q by r square. Remember, this is same like the field due to the charged shell. அப்படிதானா? 1 by 4 pi epsilon naught q by r square. நம்ம இங்கிருந்து we are moving, we are giving a small displacement and moving up to infinity. அப்படிதானா? When we are doing the same derivation, the potential we are going to get will be same value. ஏன்னா பாருங்க, electric field formula same. இங்கிருந்து we are going to use this relation, right? Minus dv by dr is equal to what? E. அதனால நம்ம யூஸ் பண்ண போறோம். Minus dv by dr is equal to what? E. இந்த relation யூஸ் பண்ணி நம்ம integrate பண்ணா same integration limits r to infinity. Integrate பண்ணா என்ன வரும்? We are going to get the same result. What is it? Potential at a point outside due to the charged sphere also same result. I am not doing the derivation again. Here same as it is we are going to do. Paranga. Electric field function same. 1 by 4 pi epsilon naught q by small r square. அப்புறம் நம்ம என்ன பண்ண போறோம்? Minus dv is equal to e dr. அதுதானா? Minus dv is equal to 1 by 4 pi epsilon naught q by r square dr. Left hand side limits will be what? V to v infinity. Right hand side la r to infinity. Same derivation we are going to do. அப்படியே பண்ணா what you are going to get? Same value, right? The potential at a point outside due to the charged sphere also will be same, which is what? 1 by 4 pi epsilon naught q by small r. Okay. Now what about the on the surface case? Means when you are moving closer and closer to the surface, right? Smaller value will approach what? Capital R. avladana. Smaller value will approach capital R, which means what? Potential on the surface. அதுக்கு என்ன? Just அப்படியே அந்த ஃபார்முலால ஸ்மாலருக்கு பதிலா will keep capital R. அவ்வளவுதான். So what is the potential on the surface? பாருங்க, these two results are same in case of the charged sphere or in case of the charged shell. ரெண்டுத்துலயும் ஒரே similar results வருது. Okay. So the potential outside is what? 1 by 4 pi epsilon naught q by small r. On the surface 1 by 4 pi epsilon naught q by capital R. But difference enga varum theriyuma? The potential inside the charge sphere. Anganade, if you look at the potential inside a shell, potential everywhere is same. Inga appadi varadu. So here we are not going to have the potential everywhere same inside the charge sphere. Okay. So if you look at any point, mark a point inside the conducting non-conducting sphere. This is what? This is the non-conducting material. Okay. There will be, so let us mark the point to be a distance r from the center of the sphere. There will be electric field here. What is the electric field formula? Already in the result. What is it? 1 by 4 pi epsilon naught q by capital R cube into small r. We done the derivation in the electrostatic field. And the discussion we done this derivation. What is the field inside the charged non-conducting sphere? 1 by 4 pi epsilon naught q by capital R cube into small r. Which means what? Inside the sphere electric field is not zero. Means if you are, if you give a small displacement dr, there will be a potential difference. What is the relation? Minus dv by dr is equal to E, or we can say dv by dr is equal to minus E. We can say dv by dr is equal to what? Minus E. Okay. Now we'll just rearrange. Rearrange what you will get? dv is equal to minus E dr. So dv is equal to E is what? 1 by 4 pi epsilon naught q by capital R cube into small r dr. Okay va? So if we integrate from that small r, we will give small displacement until we reach the surface. Means the distance from the center of the sphere is changing from small r to capital R. Potential will be changing from potential at the point inside to potential surface potential. Already I am getting the value. Okay va? So this is how the integration is going to happen. We will separately solve the LHS and RHS. We will separately solve the LHS and separately solve the RHS. Okay. So LHS mattum we will write here. Okay. Integral dv means what? It is like integral dx dana, which is what? X. So final limit is vs minus initial limit is v. Okay va? So this is our LHS. We will go to the RHS part. RHS paranga. In the full term is a constant. Minus 1 by 4 pi epsilon naught q by capital R cube. Everything constant. Minus q by 4 pi epsilon naught capital R cube. Integral small r to capital R. R dr. What is integral r dr? R square by 2. Integral x dx x square by 2 dana. 4 pi epsilon naught r cube capital R square by 2 minus small r square by 2. This is the, what is it? Capital R square by 2 minus small r square by 2. This is our RHS part. So LHS and RHS is also there. What are we calculating here? We are calculating the V value. See, we are more interested in knowing what is the final answer. What is it that we are more interested in knowing? What is the final answer? But in the result conclude we will get what is the final answer. LHS is equal to RHS. LHS is what? Vs minus V. V. So we will take the minus V to the right side. After in the left side term, we will bring it to the left. Right side term, we will bring it to the left side. Sign change. Vs plus q by 4 pi epsilon naught capital R cube into r square by 2 minus small r square by 2. That is our V value. Okay va? So Vs value mattum nama substitute panna, we will get what is the final answer for the V. Vs evada, what is the potential on the surface? Vs எவ்வளோ? What is the potential on surface? What is the Vs value? Q by 4 pi epsilon into capital R plus இது இங்க பாருங்க, we'll just divide this. Divide na, we'll just know, open up the bracket. Open பண்ண என்ன வரும்? Q by 4 pi epsilon naught R square இருக்க R cube. 1 R will get cancelled. So இது என்னது? Q by 2 ன்னு சொல்லலாம். அந்த மாதிரி minus Q by 2 small r square 4 pi epsilon naught into capital R cube. Okay va? So இங்க என்னது வர பாருங்க, this is like what? X plus x by 2, which is what? 3x by 2. X plus x by 2 is what? 3x by 2. Okay, so what is it? This is like 3 q by 4 pi epsilon naught into r into 3 by 2. Okay va? Remaining is what? This minus q by 2 into small r square by 4 pi epsilon naught into capital R cube. So we just have to solve this patiently. We know this will take some time, but solve panada we'll get the final answer. So this is our V value. What is the V value? Q into 3 by 2 divided by 4 pi epsilon naught r. அதுக்கப்புறம் minus q by 2 into small r square by 4 pi epsilon naught into capital R cube. Okay, இது என்னன்னா we can try and rearrange it. So இங்க பாருங்க, q by 4 pi epsilon naught, okay, into r. அப்படி நம்ம காமன் எடுக்கலாம். காமன் எடுத்தா என்ன வரும்? 3 by 2 minus r square by 2r square. Okay va? So this is what is our V value. So paranga, what is it? 1 by 4 pi epsilon naught q by r 3 by 2 minus small r square by 2 capital R square. So this is the final expression. Okay, so what is the final expression? 1 by 4 pi epsilon naught q by r into 3 by 2 minus small r square by 2 capital R square. இதுல என்ன தெரியுமா? We will get some interesting results. So in the formula தான் நமக்கு important. ஏன்னா மத்ததெல்லாம் it's a routine thing. Whatever we have seen in the case of the charge shell, same thing is coming in the case of the non-conducting sphere also. But difference enga varudhu? Only the potential inside. Adukku enna formula? 1 by 4 pi epsilon q by r into 3 by 2 minus 1 by 2 into small r square by capital R square. Idhula enna theriyuma? At the center of the sphere. At the center of the sphere and sonna, what is smaller value? 0. So smaller will become 0. Smaller 0 means this will be 0, which means what? Potential at the center will be equal to evlo paranga? 1 by 4 pi epsilon naught q by r into 3 by 2. You know what is this? 3 by 2 means what? 1.5. This is 1.5 times potential on the surface. So it's a very standard result. So what is it? Due to the charged non-conducting sphere, potential at the center of the sphere it will be 1.5 times potential on the surface, which means what? Surface if we are going inside means what is going to happen? Potential is going to increase, and it will be maximum where? At the center of the sphere. It will be 1.5 times the potential on the surface of the sphere. Paranga, the graphical representation V inside, it is maximum? It is maximum at the center, means the distance from the center of the sphere is 0. It's a maximum. Paranga, 3 by 2 times potential on the surface. When you come to the surface, it will keep on decreasing. It will keep on decreasing. Okay, decrease it will come to the surface of the value. which is 1 by 4 pi epsilon naught q by r. அதுக்கப்புறம் what is the function? V proportional to 1 by r, so keeps on decreasing. V proportional to 1 by r keeps on decreasing. Okay, so the function inside and function outside are different. The potential function inside and potential function outside are different, but trend ஒரே மாதிரி தான் வரும். என்னது? The potential keeps on decreasing. The maximum இதுக்கும் அதுக்கும் difference என்ன தெரியுமா? Because of a charged shell where the potential is maximum, potential everywhere inside the shell is same, which is equal to the potential on the surface of the shell. That is the maximum value. Okay, அங்கல இருந்து நம்ம வெளியே போனா it will keep on decreasing, but இங்க அப்படி கிடையாது. Due to the charged non-conducting sphere. Why are we again and again saying non-conducting sphere? Because இதுல தான் the charge will be spread in the entire volume of the sphere. Okay வா? இங்க என்னது? The potential is going to be maximum at the center of the sphere. That will be what? 1.5 times the potential on the surface. That will be 1.5 times potential on the surface. Okay va? So this formulas are important. We have spent some time to derive all these things, but திருப்பி சொல்றேன், what is the main important thing? The formulas எல்லாம் நமக்கு ஞாபகம் வச்சுக்கணும். அது ஒன்றும். ரெண்டாவது graph based questions. ஏன்னா recent NEET பேப்பர்ஸ்ல நீங்க பார்த்தா you will have like lot of problems they are giving based on the graph analysis. அதனால we should be clear in terms of the graphs. So what are the graphs we are having? Charged shell, potential graph, field graph. Charged conducting sphere அந்த மாதிரி தான் வரும். Charged conducting sphere will be similar, right? Difference வராது அதுக்கு இதுக்கும். Then we are having what? Charged non-conducting sphere. That will be different. So இதுல we have to look at what is the potential graph அந்த மாதிரி what is the field graph. Okay, பாருங்க, these are the kind of questions. So this question has come in the previous year AFMC. And இதுக்கு முன்னாடி we used to have so many examinations, right? For the Armed Forces Medical College we used to have a separate exam. அதுக்கு தனியா they used to conduct the entrance examination. இப்போ என்னன்னா you will have eligibility which is based on the NEET. NEET they will mention some cutoff mark. And the cutoff mark மேல வந்தா you will be eligible. They'll have some internal mechanism இருக்கா, like aptitude and solidity. They'll have some small procedure, but you should be getting an Armed Forces Medical College, right? It's a very coveted college. A lot of people will try to get into it. Okay, so you have to cross some threshold mark. Adukapram they will have some internal aptitude, and you will have to also I think write a bond or something, because the fees for the entire course will be very minimal in comparison to normal medical colleges. Okay, so we'll discuss about it when we reach to that stage. But inga enna parunga, the concentric spheres of radius capital and smaller have similar charges. Means you can take both of them to be positive like that. Similar charges sonna either both are positive or both are negative. Okay, with equal surface density, charge density. The surface charge density is what? Same, sigma. What is the electric potential at their common center? So their common center, they are asking what is the electric potential. Okay, so when they say that surface charge density, அப்படி சொன்னா what you have to take? These are basically what? The spherical shells. Okay, so two concentric spheres. Okay, the meaning of the concentric will be there when we talk about the spherical shells. Okay, avanga sphere and solirukanga, but it will be what? Spherical shell. Okay, now both of them have the same surface charge density. Inga parunga, let's say the charge on them are what? Q1 and Q2 nechukonga. This is having radius smaller, this is having radius capital. Q1 value evlo theriyuma? What is Q1 value? The surface area into sigma. Q2 evlo? Its surface area into sigma. Appadidana, charge will be what? Surface area into surface charge density. Okay, now the common center is like what? Center of the shell. Remember, center of the shell will have the same potential as that of the surface. Center of the shell will have the same potential as that of the surface. adukena what is the potential because of the first shell? 1 by 4 pi epsilon naught q1 by small r. Okay, so what is it? 1 by 4 pi epsilon naught. q1 is what? Okay, 4 pi cancel. I know 1 r also will be cancelled. What is it? R into sigma by epsilon naught. That is our v1 value. Rendu similar dana. So v2 will be what? Smaller ku badala enna varum? Caplar varum. Avladha. Caplar into sigma by epsilon naught. So avanga enna kekranga? They are asking the electric potential at the common center, which means what? Rendu nama appadi add pananum avladana. So when you add both of them, what we will get? R sigma by epsilon naught plus small r sigma by epsilon naught. Idhil sigma by epsilon naught appadiye common varum. So what is the answer? Sigma by epsilon naught into capital R plus small r. Another, what is it? Sigma by epsilon into capital R plus small r. Okay. Another question paranga. Some charge is being given to a conductor. Means we are having a conductor, adukku we are giving some charge. Charge value availability they are not mentioning. Okay. Then its potential is, they are asking about the potential concept. Paranga. Statement elenna maximum at the surface. Okay. Statement B la maximum at the center. C la remaining same throughout the conductor. Option D, maximum somewhere between the surface and the center. This is general question. Already discuss pannirukom. What is it? If you have a object which is made up of a conducting material, when you move from surface to inside an electric field is 0, which means what? dV term irkadu. dV will be 0, which means what? Potential at any point inside, right, will be same at the center or wherever you take. Potential at any point inside the conductor is same, and the value will be equal to potential on the surface of the conductor. Okay, wow. So what is the correct statement paranga? What is the correct statement? It is option C. Potential remains same throughout the conductor. Everywhere inside the conductor potential will be same, and the value will be same as the potential on the surface of the conductor. The value will be same as the potential on the surface of the conductor. So it cannot be maximum on the surface. It cannot be maximum at the center. In fact, potential at the surface, right, will be same as at any point inside the conductor. Potential at center will be equal to potential at the surface, right? Option D lena solranga maximum somewhere between the surface and the center. Idi kadayadu. Because all the points between the center and the surface potential will be what? Same. Okay, wow. So what is the answer for this? Option C is the answer. So this is an important area for questions in the NEET examinations. The electric potential due to a charged shell, which will be same as charged conducting sphere. Rendu ore madar results. And the electric potential due to a charged non-conducting sphere. Okay. So last nama nariya time spend pannikku theriyuma the derivation. The potential at a point inside the charged non-conducting sphere. Adhula we have to remember that expression. Adukapram we should also remember that important result. Another potential at the center of the sphere will be what? 1.5 times the potential on the surface of the sphere. Because right, when they are giving some questions on these kind of areas, they will try to pick up some standard results. On the standard result based they will try to give the questions. Adanala we should try to look at all the standard results. Okay, va? And importantly the graph analysis. Okay, so this is what we have to study about the electric potential due to the distributed charge systems. Okay, another class we will start with the potential energy of a dipole. Potential energy of a dipole which is kept in the uniform electric field. Okay, so adilende we will start. Adukapram we will go to the the behavior of the conductor. Maybe adi mudichittu we will then go into the discussion about the capacitors. Okay, va? So we will see in the next class.